Hi, everybody. Good evening. It's transforms your data right there in your data warehouse. You are not just moving your table. It depends on what you configure or what you set as the result. So it is a very simple logic that it is going to take it to return as a view or as a table. It is going to get transformed as that the back end is going to create a table based on your pipeline architecture, because I explained that in recent times data is too large. The normal flow for data pipeline is the ETL, right? So you extract, you transform, and you load. But this was a workflow is no longer as adaptable or feasible in recent times, because we are working with large amount of data compared to how it was years back. So because of this approach, really best practice to first of all load your data into your data warehouse before you carry out the transformation. So that's why DBT is a very important modern day architecture tool, because it's a tool that supports the modern day ETL workflow of extraction, loading, then carrying out your transformation. So today we're going to continue where we stop from building hands-on with we are going to now build hands-on with DBT. We're going to create models. We are going to set up configurations that's going to define how our models will be built by DBT. So we're going to tell DBT whether to build the model as a table, or if to build the model as a view. So I'm going to share my screen now and take the video and understand everything that's a complete the model. So please just ask any questions and drop in the comment section. Looking at the comment section time to time, my colleagues are there and we would attend to it. So let me just share my screen now. I'll continue where we stopped yesterday. Okay. Okay, so yesterday, I hope you can see my screen. We were just about building our models from our models to transform the data in our database. And I'm currently spinning do a brief recap of showing the data that we have in our database and the type of transformation we want to do to it. So in case you were not a part of the class yesterday, or you're joining us for the first time, we are working again with DBT again, just as I said. So these sections are the columns from our raw data that we want to transform. So like I said, so it does the transformation there and give you a new table. So from our warehouse, we currently show you the data view. So from our warehouse, we currently have the data view. Actually show you the data running there, and I can't also show you the exact raw form of the data. So yesterday we also created the source.yml. I told you source.yml is the view that we are looking at as our raw table. Was to perform a staging sale, like a staging transformation on the data coming from Bankole store, which is the table that we are looking at as our raw table, right? So this table, what it is as a view, is that is going to create, it will run all the compilation at the back end, and it will return a view in our database. So it will show you the data in our database. That's what I mean by materialize as a view. So that was what this was meant to do. So based on that, we can then come here to our models, to our source.yml folder. Because this source.yml folder is like the book of life for the for DBT. So it is true you have models you are running. So it will show you what you need to do in the source.yml. I also mentioned something yesterday. So in case you had in another syntax file, it's not necessary you name it source.yml. Yes, there are some files in DBT that you need to follow the exact naming convention. Example, the DBT underscore convention. In fact, DBT init. It is part of the files DBT produces for you. So you have no other choice. It will be there in your repo in that way. Another example of the files that DBT doesn't play with is the profiles.yml. It will search specifically for a file named profiles.yml in your home directory. So you don't need to bother about that, because again, once you do your DBT init and you put on all the configurations, it even creates that file for you itself, because it is a file that must never be missed. But something like source.yml, the only thing our DBT is interested in is the .yml. So I can name it anything I want .yml. But as long as there is a .yml file in my model folder, it will be good. So it doesn't matter what exactly you name it. So in some places, you can see it as schema.yml, it's still the same thing. Some people can even name it config.yml, it still means the same thing. As long as it is a .yml file inside your model, it's going to act as part of your model. Okay, so I just thought to point that out there, because I know some documentations and some. Okay, this is running now. Very good. So just give a second. Let me just set this up. up our, let me just run our Postgres database and put in our Berkeley study needs to end with a .yml, and it have to be in your model folder. So now that we've already defined the source, we have just one source of this data. So it would like other tables or whatnot. We can also add to this list because this is a list. The thing about YML file is that if we are saying it give this hierarchy like a slash, you know that this thing can be created as a list. So this not list like it is another table, that kind of situation. Add another name, then add the name of the second source, right? So let's say second source is, we'll just call it bronze, doesn't matter, anything you want to call it. Then what's the other configuration of the source? We'll check for the schema name, follow the setting, follow the mapping of the YML file. If you notice the mapping, the next line that is a configuration underneath a parent's configuration, it has to be sent in that space. That's going to underline like a parent-child situation. That's like that's the way YML is configured. So writing a YML file is the most easiest language to write because it's just a documentation style. It's not that there necessarily is any different language or whatnot. It's just a documentation style. So as long as you learn to put the documents in hierarchy, the ones that should be under a parent's header, put it that way. So there's no big difference in writing a YML file. It's just a style of documentation, in my opinion. So then let's now say this one, the table name. The table is um the table is, let's say it is, let's just say, right? So you can add more lists onto it and make it work. So just give me a second. We have everything up and running. Okay. So now that we've configured the source, and this source is what we're going to reference in our model when we are creating it. But now we know that we are about to create a new model named stgsales.sql. So we are going to also start the configuration on that. So now we are going to now tell source.yml. This is the configuration for the model I'm working on, right? So what is it you have to configure? It is obvious that you have to get stg sales per source.yml file properly to um, to reflect what is okay. Okay, give me a second. This has to go. This has to go. This has to go. Okay. Okay. So now let's go back to our look at the what we have for our database comes up. I'm going to then once it comes up, I'm going to do a recap again of showing you the data currently. Okay. Okay. So I hope you can see my screen because now I'm sharing our slide. So we'll be starting with model. We'll be starting with a DBT model because I explained yesterday already all the configurations that everything stamation your warehouse. So if you can successfully connect to your warehouse, it will catch the configuration easy and you know exactly the next step to take before it actually crashes. Okay. So now that we have that set, so confirm that DBT can act to our data warehouse even before we start building up our model. So first thing first, we are going to run our DBT debug. So this is automatically using all the credentials that we set up in our profiles.yml file. So those credentials is what is going to use to attempt to connect to the database. So if it's successful, it will let us know. If it's not successful, it will also let us know. So we'll know exactly where to move on from there. Okay. So we can see here that our connection test was successful. It passed all the check. So what it checked for was to make sure that the database exists gold. The database where our data currently is, which is staging, it exists. It ensures the port exists, and our host is localhost because I changed the host to localhost because I'm running the Postgres on my personal system. I'm running it on my local environment. So hence our host to be localhost and the port to be 5433 and so on and so forth. So let me just confirm right here and show you on using the PG. So we will see exactly how the data is sits locally stored data. So just to give you some time to log in. on our DBT, we will have to convert that to local host because this is a local thing is our database. In database we are working with is the staging database. So we can see it right here. Then after the staging database, the schema we are working with is the public schema, which we can see right here. And we also have our gold schema where we into this gold schema. So now our public schema is where we currently have our raw data. So if you look at the tables in our public schema, so just let's load. And now let us view what is in bank college store. Hold on. Okay, hold on. I'm yet to load data into Bankole store. So just give that time. Just give that time. Okay. The job is still running to load data into our Bankole store because we have to use that data to practice our transformation. So just give that a little bit of time to complete. So once that is done, we'll move on to start building our model. So I believe this is still running. Okay. So the next thing we're going to look at while that is being set up, I'm going to let me share my screen once more. So the next thing we'll look at is on theory. We are going to look at what a DBT model is because I don't want to start building yet until you have seen our actual data in our database. So like I explained, that DBT model is fundamentally an S.SQL file, which I corrected yesterday that it can also be in form of Python, but it is most commonly used to perform DBT with SQL. So it will just be a straight transformation in your database. So it will be stored within your models directory, which again DBT automatically creates for you. Whenever you do your DBT in it automatically creates a model directory which you are expected to put all your model in that directory. So each model must contain a single select statement. What it means is that even when you perform your transformation, most likely with your CTE common table expressions, which is like your with statement, that's the best way to be able to set up the stage to transform your data. But at the end of the day, it has to work with with a single select statement, which will be at the end of everything you've defined. That might be confusing, but you will see it better once we write it out in real time. So unlike traditional database development, that's how database actually is developed in the normal sense. In Net is definitely developed with like a DDL language, which we use like the create language. We have to say create table or we say drop table and so on and so forth. DBT doesn't work with that. But what it does is that it takes your select statement, your simple select statement, then at the back end, it compiles it to then form all these DDL languages and handles everything for you. So I just hope this is actually done now. So just sort this out. Just let me check the log here. So she should have started this data. Good. So let's refresh our database and confirm that we actually have data now in Bankole store. This store is about. So this is like a store that's like an e-commerce shop. It contains the invoice number, stock code, the description, which is basically like the description of the products being sold, quantity, invoice dates, unit price, customer ID, and country. Is that's the raw data we're looking at. Now, the amount are not even in the right way. And if we want to perform transformation analysis, like if you want to give to analysts to actually perform analysis on this data, they might not get accurate results because the data is not in the right format. And this is part of the job of a data engineer to make sure not just that the data is available, but the data is in the right format. Okay. So based on this, let us create, and I told you that the flow of what we will do, that in terms of the models we are creating, we are going to create two different models. So the first model is going to be a view. It is going to just simply transform this data, give it the correct data type, the correct column name, and so on and so forth. It will make sure everything is like in the right space, in the right format. Then we are then going to create another model which is going to get converted to a table, and this model will be like a summary indices of what is on this table. So it is going to create like an aggregated layer of what is on our raw table. So that aggregated layer is what analysts can now easily analyze to gain meaningful information to give back results to the business. So even aside the wrong data type, if you can even see clearly from some of the files written here, you can see here that most of them are not even trimmed. We have some with some leading space at the beginning, we have some with some leading space at the end, and this is going to also form in incorrect data being returned during analysis. So first thing first, let's go back to our STG sales. Now that we are sure our database is up and running, and DBT can also see our database because the connection test was successful. Now let's start building our model as discussed yesterday. When you're building your model, the first thing that should be in your model file is your config. It's called config, confg, and config will be in a double bracket. This is how it's formed. Config will be in a double bracket, and we'll give this space, dbt like space. So once you set your config, in your config is where you are going to set up every information that the model is going to use to build your logic. So once you set up your config, the first information that goes to config is a materialized. You are trying to tell DBT that, okay, when this model gets materialized, that's when it gets compiled, or when you perform all your magic on the back end, how does it want to return to the destination? In this case, I told you we are going to set this staging as a view. So I'm going to tell the config that materialize this set as a view. Now, there's something I wanted to mention, that there are actually still different type of materialization. It can't be just view and a table. You know, in some cases in like telecommunication business where data is being loaded every day on the database, they mostly use a type of logic called incremental process. I don't know if you understand the word incremental, like what when something is incremental in real time means that it keeps increasing every day. It keeps getting added to it, right? So this type of process is a better process being used in most big data companies because it just appends onto the current data that they have. So if it is not just a view, and I wanted to clarify on this because I remember mentioning yesterday that it can create either a table or a view. Now, the interesting thing about incremental is that if I should set the materialized as incremental, right, it will still create a table because an incremental logic, it is still a table. But in this case, it will create a table in such a way that it will, anytime it is getting data from the source, it won't just be reading everything from the source. No, it will only start reading from the last time it picked up from source. So you can see how it will support the incremental loading into our own database. It's only going to pick data from the last time it's read from the source. So imagine your source has over 5 billion records, but obviously it's just recording about 1 million per day. So instead of these DBT going through the whole 5 billion records, it doesn't concern it. No, if it sets as incremental, it's only going to look for where it stopped the last time it went to the source, and it is now going to pick up from where it stopped. So in this case, it's only going to read about 1 million files, which is most likely the files, 1 million records, which is most likely the new records that it is looking at based on the incremental strategy. So that's just something I wanted to point out, because I remember mentioning yesterday that the two types is either table or view. Now it might get confusing because incremental will also get loaded as a table, but the loading strategy differs, is different. It's not just reading everything again on the source. No, in this case, it is just reading from the last time it stopped. Okay, so just note that there. But for this our first model, what we'll be creating is a view. So we'll be setting the materialized in our config statement to be reading from the view. So now the next thing next is that we're going to create a CTE statement, because like I said, DBT accepts just a single select query at the end. So you cannot come and be running different select statements or even creating functions, nothing as such. The best approach to perform all your transformations, and I'm not sure if my screen is sharing, I can't see this sharing. So the best approach to perform all your transformation to make sure that you would have a single select statement at the end is through something called a CTE. So let me just type it out in our code here. I'll still delete it. Common table expression, a CTE. So CTE is, I know Folonshaw must have covered this during our SQL class, but for the sake of DBT, I'm going to go over it again. So common table expression is a process by you have a complex query you want to run. So in this case, DBT is actually complex queries you are trying to run. So you can define a temporal table with your with statement. You can define a temporal table with your with statement, and once you define this table with your with statement, you can put in a bunch of selects there. You can list about 10 tables in with your CTE, and at the end of the day, you can now work with those 10 tables and bring out just one select statement. So it might get confusing. The way you define a common table expression is with your with statement. So we'll see exactly how to define that with using our applying it on our SCG sales model. So the first with statement is that we're going to now say with source. So in this case, source is like a temporal table name, or let me just say with data, so you understand better. So data in this case is representing like a temporal table name for what I'm about to type right now. So with data as, we are now saying that the value of what will be in data would be select all from, where are we selecting our data from? Remember, we've already defined our source. So we defined our source as raw, and we defined the table as Bankole store, because that's the name of our table in our database. So we are going to specify that we are picking this data up from our source. And what is the name of the source? The source column, the source function takes two parameters. It will take what is the name of the source as defined in your source.yml, and the name of the source as defined in our source.yml is raw. I can show you again here. The name of the source as defined in our source.yml is raw. So the second parameter after defining the source is to then define the table name. So in this case, the table name from our source that we're looking at is Bankole store. So this will be the second parameter we'll be setting right here, Bankole store. So now we have that with data as select all from our source, the source name, the table name. So right now, the value of data is everything that is in our raw data, aka everything in Bankole store. So every single information you see right here is currently residing in our temporal table called data. So once we set this like this, we can now set up another temporal table name. So we can now set up another temporal table name. Let's just call it staged. Let's call it staged. So we'll now say stage, the value of stage will now be that it is now going to pick from data. So right now, remember, data already has like multiple information. It has all the information from Bankole store. It has all the records from Bankole store. Now we'll be creating a new temporal table called staged that will be doing transformation from all the data on Bankole store, right? Which is aka all the data from data. Okay, this might get confusing. I can't say data from data. I need a name. I'm not really good with naming things. So what should we name this a temporal table? So let's just call it temp. Right, this is better. So with temp, I'll select all from source, then the name of the source and the name of the table. This is perfect. So now let us select from our temp, which has everything for Bankole store. So these are the columns we're working with. I wrote them out here yesterday, so we'll be able to easily track what exactly we will need to change. So we have our invoice number, which I believe should be an integer. As you can see right here, it is being stored as a text, but this is not a text. This is an integer. It's being stored as a text, but this is not a text, it's an integer. But another thing you should look at is that this is the business logic. This invoice number comes from the business. So it's actually a best practice to actually store natural numbers like this as text. But regardless of that, the way the column was spelled is not a very proper column name because it might get misused, right? So based on our temporal table we are creating again called staged, which is going to read from our temporal table called temp, we are now going to start our new select statement. So now our new select statement will be, first of all, let us convert invoice number. So we are saying we are going to select invoice number because this is how the column is currently on temp, but we don't like this. So we are going to select invoice number, then convert it to a better column name. So we'll select it as invoice underscore number. This is a better naming convention for a column, and it will be easier for you to easily, write it out and be able to analysts to be able to use it better. So this is the first transformation we've done. We've converted the column name from invoice number in the weird casing to proper lowercase for all the figures. Now the next step is to the next column we are looking at is stock code. So let me also copy this and paste it right here. This is the next column we are looking at, which is stock code. Now, how does stock code work? Let's go and check our data to see what we have in stock code. So stock code is also being stored as a text, but yes, we can see that is adequate because the data contains not just integer, it also contains letters attached to the integers. But the one mistake that can happen is that it might not be trimmed. It might have like some white space before, it might have white space after, it might just have all these type of configurations that will make it easy to have duplicate records. So based on that, we're going to make sure this column is trimmed. So there's a logic on SQL called trim. So this trim function, it is automatically going to trim your column, the value in your column for you. It will take out any space before in front. It also take out any space behind, so to make sure that it is just your value that is going to sit in the column. So now we can now select our the next column we are looking at. We're looking at description. So let's go back to our database. As we can see, we have our also looks like it might have some spaces in which might also lead to duplicate values. So what we can do to make sure that we are not having any duplicate values, we will also apply the trim, and we would also apply a uppercasing to make sure that even though from what we can see here, it looks like all Oh, so sorry about that. I got kicked off the section and I didn't know. So let me just share my screen again. Then we'll continue from where we stop. But please, before we continue, I'm not exactly sure when and where I got kicked off. So please, if you can let me know the last thing you heard, or the last thing you understood, or the last flow you stopped at. So we'll pick up from there. So just put in the comment section. Let me know the last what you heard last. So we'll pick up from there. Okay. Please, am I audible? You were talking about converting data, converting data. Okay. So which of the, you know, we've converted lots of data. So which one exactly were we converting? Which column were we working with? Because we were converting the data types of all the columns, so we ensure that they are being stored the right way. So I want to know the column we were working with. So we'll move on from there. Stock code, stock code. We have a stock. Oh my God, that's the second column. Yes, that's the second column. Okay, so we'll start again from the second column. That's fine. So that was the second column we were working with. That must have been far back. My screen went off. So we're working with this column, and I mentioned trim. Yes. So I mentioned the trim function that's going to help us to trim our database. It's going to help us to trim our data in our column to ensure that there's no empty space in front, there's no empty space at the back, but it is containing just the value it needs. So it's a very important thing we would need for a column like this, that we want to ensure that every single value there is unique. Okay. So once we do the trim function, we apply it here. The next thing we also do was to convert the column name. We'll now save it as stock underscore code, which looks better. Now, the next column we looked at was the description column, which is the next column in our database. And as you can see here, that the database, the description column is also stored as a text, which is fine because the values here are text. Okay. But now what I want you to look at now is that the description column might also have the trim issue. That it might have the issue of some leading and lagging space behind and after. And not just that, even though from what we can see, everything here is being stored in uppercase. But what if not all is being stored in uppercase? It might cause a miscalculation later on. So best practice, I used both the trim function and the upper function on our description column. So in this case, I use the trim function, and inside the trim function, I also apply the upper function. And what the upper function does in SQL is that it's going to convert your results into uppercase. It's going to convert your results into uppercase. So this is what it's going to do. And the column we're working with is description. And once it is done, it will rename the description column as description in small letter. Now, once we are done with this, the next column we looked at was the quantity. And I explained something that from what I can see here, the values in quantity are small. They're like small numbers, right? But as you can see, it was stored as a big int. And I said that big int means big integer. It means the data is being stored as big integer. But in real time, as we can see here, that the data is not a big integer, it is just an integer. So to save space on our database, it is better we cast this database as it's better we cast that column and convert it to a normal integer. So this was where I was explaining the function cast. That cast is a type of function that can be used to convert data type of a column. So in this case, our column was previously a big int, but using the cast function, we are now telling cast, okay, cast quantity as integer. Then we give it an alias of quantity in small letter, which is a more appropriate for a column name. Now, the next column we looked at after quantity, we have the invoice date. And as you can see, the invoice date, it has both the date and the time. So this is more like a date time column, right? It has both the date and the time. But as you can see, even though it has a date and time, it is being stored as a text. This is not appropriate. So we are also going to convert this to a date time column or a timestamp. This is what we are going to call it. I converted this to a timestamp. I converted to a date time. I think I would actually prefer to use timestamp. So let's do try to timestamp. This is okay. We are going to use to timestamp. So what are we converting to timestamp? This is the column name in our table currently, but we are converting this and also renaming it as invoice underscore dates. So this was where I stopped before I realized that my network went off. So after unit price, the next column we can see, after invoice dates, the next column we can see in our table is the unit price. And as you can see, that unit price is okay. It has just the float data, and the float data can be stored as a double precision. This is okay. So the data type is okay. The only thing we just need to look at in this case is probably the naming convention of the column. So in this case, it is being stored as units with capital U and a capital P, which can get confusing. So we're simply just going to carry this column, then we will name it as price. This is much more preferable and this is neater in flow. So now the next thing we'll now do, we'll look at our next column. So the next column we have is the customer ID. And you can see it is being stored as a double precision, which is not correct because from what I can see here, customer ID is just it looks like a regular integer. The customer ID looks like a regular integer, so I do not believe this should be stored as a double precision. So we are also going to cast this as integer. But as you can see that it can even be casted as a big integer because the numbers here are quite large. So we can actually try to convert this to big int. So we will say cast, what is the column name? The column name is customer ID. So we'll be saying cast customer ID as big ints. I'm also going to rename it properly to small customer, then ID. So this is okay. So we're going to rename this to customer underscore ID. Let me put underscore here. So same thing with, I just remember that we could also convert invoice number to big integer because from what I can see here, those numbers in the values in invoice number, they look like all of them are all going to be numbers. So we'll convert that to big integer also. I didn't even spell this word. This is invoice with the O. Now the last column we'll be looking at in our table will be country. And you can see country is stored as a text, which is fine, but it's with me, it will be a very big error if the country name is not unique, right? So to ensure that the country name stays unique, we are going to convert everything to uppercase. So even if there's a hidden country name in a lowercase, it won't reflect because we've already transformed it to be in uppercase. So everything will be unique and at the same page. So this is the last column we'll be working with. Let me now delete this from there. So we'll be converting country to uppercase and we would name it as country. Okay. So there's one more thing I want to say about the cast statements. Sometimes it might have some values that might be stubborn. So one of the best way in production to use the cast function is to use the try cast. So it is going to forcefully try to cast the value to um the data type that you want it to convert to. So cast and try cast, it will still give you the same result, but try cast is much more preferable because it's a way to ensure that that conversion actually happens. So I actually do prefer using try cast to a regular cast. Now remember, where are we getting our data from? We've already created a temporal table previously called temp, and it contains all our data. So in this our select statement, when we are creating stage will now be getting all this data from temp. So now you can see the flow. Temp picked up all the data in our world database, and even though this is redundant, we could have just easily also done with stage as then with our form statement, putting all these values here. But I wanted to just show you step by step how everything is being understood. That was why I first of all created a temp table that will temporarily store all this value, then another table that will then perform the data conversion and the naming conversion and everything. It will be getting the data from temp, which we created earlier on. Now we've seen that we've converted our data. What's now the next thing to do? Give it a select statement. So the next thing will be the select statement. We'll now be selecting all from what is our table that has our conversion staged. So you can see what DBT means by it would accept a single select statement. But if you're seeing that we have about 3 select statements in this model, but the select statement that will matter will be the final select statement that will be returned after your common expression. So the common expression builds two temporal tables. The first table is built as a temp table, comma. Second table is built as a stage table, which read from the temp table. Now, based on this, we then defined our select statement to read from staged. So this is going to be our first model. So I did a Control S to save this model. So now what are we going to do? Let's go to our source.yml and make sure we've already defined the column that this model should expect. So as you can see right here, we've already named it as STG sales, which is the name of our table, which is the name of our model. So now we're going to define the columns that are in that model. So what are the columns in the model? The first column here we have is invoice number, which is this. And when you're picking the column in the model, it should be the new columns that you transform, because that's the columns that will be reflecting in that model. Because again, remember, the model is going to convert to a table or a view on your database. So all these columns you transformed are going to be the actual column name that will be in that view or your table. So in your source.yml file, the columns you indicate here will be this. And we can give it some form of what do you call it? Oh, I didn't specify the name. Before we do that, the column, we need to give it the name. So what's the column name? Column name is this. Now what's the next thing we'll do to this? We can give it a data test. So this data test is going to confirm the different constraints that will be applied on this model. So as you can see, that invoice number, this is a store, so the invoice number should be different for each. Let me confirm that. So the invoice number should be different for each of this store. Okay, we see it's not different. Okay, so the data test we can do here is, should we set it as a not null. So we are telling dbt that when this data gets loaded, you should make sure there is no empty value. Everything must be complete in this column. That's what we mean by defining invoice number as not null. So the next thing we can now do is we now create the rest of our column. So what's the next column name we have here? We have stock code. Is there any data test we want to give to stock code? Let's look at data. Is there any data test we want to give? Not necessarily, because they don't look like they're unique numbers. They don't look like they're unique numbers. So let me confirm that. Um, they don't look like unique numbers. So let me just leave that as it is. Then the next column that we have in our model would be description. The next column we have here is quantity. The next column we have name is, the next column we have is invoice dates. Then we have the unit price. Then we have the customer ID. The next column we have is country, which is the last column in our model. So now you define your source, you've already specified again your source.yml, all the columns that we're expecting to come from stage. So now that we've defined this, we've defined the source, we've defined what's actually in our model. Now let's run our model. When you run the model, you run it with the dbt run. That is the syntax. When you're running your model, run with the dbt run. So let me show you how it looks. So once you create this file, you're going to run dbt run. So what this does is that dbt will materialize this query as a table or a view. In this case, it's going to materialize it as a view because we define the materialization to be view. So once it does that, we'll then get our results. Let's just see this in our terminal. So we'll just run dbt run. So this is going to go into our look. It will look for any model in our model folder, and it's going to run that model to give us a result. Okay, it is starting the run. I hope you can see my screen and all the configurations being returned. Okay, raw.bankole data store was not found. So let's go back to our source configuration. This is reading from public. So it should define this as, let me just name this public. Let's name this public. So this should be reading from public. Okay, so now let's run our dbt run again. Okay, so it's a public.bankole store was not found. So let's go back to our database. Public.bankole store is actually available, so I don't know why it's not showing that. Let me confirm this is available. Where dbt is. The connection is okay. It is reading from our staging. We can see here our user Postgres. It is reading from staging. So I believe this should actually be fine. So what then is the issue? Public.bankole store exists on our database. So let us run dbt run again. and ensure this actually exists. Okay. So again, let me be sure DB is actually reading from our proper file that we created right here. So I'm going to share my screen again. Let me confirm this is correct. Please, I hope I'm audible. I got kicked off again and I didn't know. Sync network is really, really poor today. Can you hear me? Please, am I audible? Please, am I audible? Hello. My network is really poor tonight, so I'm still trying to ensure that we are together. Okay, yes, I'm audible. Thank you. Sorry, I was not seeing the comments. Yes, I'm audible. Okay, let me share my screen back. Then we'll move on and try to configure where exactly it's getting the error from. So that's about coding live. We'll both see in real time where the error is coming from, and we'll be able to debug together. So when we have our compilation, we should be able to see our error message and know exactly where to debug from. It is telling us that it depends on a source named public.bankole store, which was not found. But then, as we can see from our database, Bankole store exists. We have public.bankole store existing in our database, and it's actually found because we have it right here. So let me just confirm and know exactly what this is being registered in staging database. So our specific okay, we have that staging, and we also have, okay, just give me a second. Oh my god, I think I've gotten, I think I can see I'm still in the show. Okay, I think I believe I'm audible now. So I'm still trying to understand why DBT can't see our public. Okay, so this should be reading from the store. Okay, let's check our DBT .yml. I'll call you back. Just miss out. So let us define our model right here in our DBT underscore projects. But even though this should not actually be. This shouldn't be the indicator. Yes, I'm saying anything. Yes, I'm saying something, Joey. Okay, so we have it from source. We have it reading from source to public schema to store. So why exactly is it not reading? Except my DBT is using a different profile that I'm not sure of. Apologies again. Very difficult. Having very poor network connection tonight, and it's been logging me on, off and on, off and on. And I'm also trying to pass in our data right here from public.bankole store, but for some reasons DBT can't find, or it can't access that exact port. So we will have to configure it from the we'll have to configure it to see what it is speaking from. User, we configured our DBT profile to work with what we currently have, but I'm trying to see is not clashing with it. So that is the man. That's actually my concern now. Okay. Yes, the previous project is actually clashing with this. Okay, so let me delete the previous project that is clashing with this, and we are going to then run our DBT run to ensure that this actually is going to give us what we need. So just give me 1 second, and our time is actually far spent today. Oof. Just give me a second there. Okay. So we have our database name as staging, we have the user as Postgres, the password, then we have our ports at 5432. Okay, this is the reason of hosting on your local, and it is not going to exactly give you exactly what you need. So let me delete this profiles.yml right here. So we're going to use this. Okay, okay, just give me a second there. Okay, so let me move our database to this current directory where we are working with. I think this will be the best way for us to actually have, that's our database network. I'm going to move it onto our project directory so DBT will be able to recognize it properly and work with it, because the way it is working right now on different directories, it is not connecting properly to the database. So that's why it keeps showing the error of it can't find the source named public.bankole store when it actually does exist on our database. So let me do a dbt clean. So the dbt clean, then we are going to do a dbt run again. Okay, so apologies, everyone. We are going to have to move. I'm going to have to move my database onto the current project we're working on. So there won't be a network clash, and we can easily override that configuration. So our DBT will be able to easily work with what we have on our Postgres database, because it is not a open database. I'm just hosting it right here on my local system. Hence the reason for all the configuration issue and whatnot. So for some, DBT can't recognize my schema and table in my current database being hosted on my local. So we would have to configure that to I would have to configure that to actually read from there. So in this case, I would have to, for more information, you need DBT predators. Okay. Okay. So don't let me keep us waiting here tonight. I'm going to have to end the class to this evening, because without this database configuration, we can't actually we can't read from our source. So this is actually a bit of poor planning on my end, but I thought the connection was going to be able to go through. So we're going to come back tomorrow to complete on this. So we're going to read from our raw storage source, then properly do the transformation into our schema that we created. Okay. So this is just a brief showstopper, but by tomorrow we are going to configure this together, and we are going to see how it will configure and write into our schema that we created. Okay. So thank you for your attention this evening. Even though there's been a very big glitch, I'm still going through the log to identify exactly where it's been where it is having the error from. So this is actually meant to read from our incubator folder, but it is reading from the different folder, and also it is not even connecting to to the database that I set as the local host. So that's also part of another issue why our DBT can't actually read from this source, our public.bankole store. So by tomorrow when we come back, we are going to configure this together, and we will see exactly where the error is coming from. So thank you again for your attention this evening. and do have a wonderful rest of your evening.